Okay, go ahead.
Okay, so this is the results of the B.A.R testing. This is the left ear and this is the right ear. This is time going up from the inner ear through the brainstem in milliseconds. This is a loud sound of 80 decibels, and what we expect to see as it's moving up from the inner ear up through the brainstem is these spikes. And this is the neural activity of what's happening in the auditory nerve. So as it hits this area of the auditory nerve, there's a burst of energy, and you get this spike here. Now we've moved farther up the system. Now we've got another burst of energy, and then another one. And we label them. We're mainly concerned with these three we call 1, 3, and 5. So this is the right ear at a loud sound. This is the left ear at a loud sound. These yellow shaded areas represent, for her age, where these spikes or bursts of activity should be. And they're pretty much right on target, okay, for 80 decibels. But we want to see how soft can we get and still see that activity. So I brought it all the way down to 20 decibels. And waves, the first couple of waves tend to kind of disappear, but we do see a very prominent, what we call wave 5. Right here, again, in that shaded area, right where it's supposed to be for her age. And the left ear, I've got another one right here. This is a mid-high frequency sound of about 2,000 hertz. So what I did was I went down in frequency to 1,000 hertz. So now we're looking at left and right at a high intensity of 80 decibels. So we've got really nice big spikes. But then I took it down. We would expect it to be down to about this level, which would equate to 20 decibels from doing a hearing test. And again, you can see a very nice prominent wave pattern here. Not quite as good, but I just increased it a little bit, so essentially normal. Then I went to a higher frequency, and we're seeing kind of the same pattern. Again, at a loud level, we've got nice big spikes, but I'm able to take it down to the equivalent of 20 decibels on the audiogram, and we're still seeing that nice wave 5. I also did, so this is me looking at it and interpreting it, okay? I also did a test where it's totally automatic, and it's doing 4 frequencies in both ears at the same time.
Okay.
And it came, and so it's, the computer is doing all the interpreting on that one.
Okay.
And it started out at 50 decibels, went down to 30, so it's looking again for this response. And it ended at 20 decibels for all the frequencies in both ears.
Is that low?
So that is low.
Okay.
20 decibels would be our normal range, 0 to 20.
Okay. And it came back.
So if you look at the audiogram, so this is the first audiogram I have from July. So here's our 20. So here's soft to loud.
Okay.
Here's our pitch, low pitch to high pitch. This was in July. Circles are the right ear, X's are the left ear. So we were kind of in the mild hearing loss range, okay?
Okay.
Then we went to August, pretty similar. Again, here's our 20. But then what happened in October, smaller diagram, but again, here's our 20. Here's our responses way down here at 70. So that's quite a change from just in the mild to here, okay?
Right.
But if I was to plot my results today, I would have all the circles at least 20 and all the X's at least 20 across the range of 500 to 4,000.
So back to mild to moderate rather than...
That would be within normal range. So now, to my findings today, would estimate normal hearing in both ears from 500 to 4,000 hertz. So it is not consistent with that.
Wow.
But all my test results are consistent with themselves: normal middle ear, normal inner ear, normal going up through the brainstem. So the only thing that's left out of that equation is what's happening at the cortical level.